Hi guys, welcome to our first Scientist of the Week. Our inaugural guest is Joe. Joe is an engineer. So our first question that you guys come up with for Joe is, did you ever think that you would be an engineer when you were in middle school? So that,
Oh, that's a great question. So I've always had engineering influences in my life. My dad was an engineer, and so there was always kind of this background of making things, building things, tweaking things, and so it was always kind of uh, there in the background. But I remember in middle school, actually, in my middle school yearbook, I said that I wanted to be a pilot, and then I also said I wanted to be a lawyer. So I don't think it was like set in stone by middle school.
there you go. You got
But
close. Pilot, you
you
were on helicopter.
pilot was close, yeah.
Knew you like things that fly. You were on it.
Exactly. It's in the same area, same relative area.
There you
But
go.
I think a lot of the influence comes in in college in particular, because you get more of a chance to explore, I guess, more in-depth classes and coursework, and that really helps kind of direct you in a direction. At least for me, it did.
Yeah, so it definitely sounds like it took you a little while to figure out what you actually wanted to do. Yeah.
Without a doubt.
Yeah, it's pretty much true for everybody. So it's good. All right. So the next question I wanted to ask you is, do you have fun on the job? Do you have a good time?
Um, Another great question. I think you should definitely have fun when you when you work, especially when you have to work every day for the rest of your rest of your life. Not to be bleak, but
Yeah.
I do. I actually really like my job. It's a really great blend of. So I'm a designer, which means that we do a lot of computer work, putting together like mechanical systems to test components on the helicopter. And so what's nice about my job is that there's a lot of hands-on aspect to it too. And so um, my day is, I would say, 75% on the computer, working on CAD software, which is computer-aided design. So it's like SolidWorks or like Google SketchUp is another example of CAD. And so you kind of design parts, you put them all together, and then what's nice about my job as a test designer is that the tests go on with almost sometimes like the same year in the same month. So you'll design a part, you'll draw the part, which means you make kind of like a Lego booklet on direction manual on how the parts go together. And uh, go into we have a lab, and in our lab you put the parts together, and then they're actually used to test things like, and the turnarounds could be as quick as a month. And so I have a lot of hands-on parts of my job where I get to go downstairs to the lab and help assemble and troubleshoot why things don't go together, why things are breaking when they're not supposed to be. And so I love that part. That's really fun for me.
That's awesome. So you get to go all the way from like it being an idea on the computer to getting to use it in real life and seeing how it actually like works together.
Exactly. And I think the only sacrifice is that I'm not designing helicopters, which definitely has some glamour associated with it. But I get to touch the parts, I get to look at them, I get to understand them.
Yeah.
But and I think that's the trade-off. But I am very happy with the trade-off because, like I said before, it's really satisfying to see your parts put into action.
Yeah. One of the questions that didn't actually make the list, but it kind of leads into what you were just saying was, what did you ever have any tests that don't really go your way, and how do you deal with that? I thought that was a good question, but
Oh, that's a great question. Let me think about tests that didn't go my way. Um, that's a great question. That's very specific. So nothing catastrophic, I would say, but
that's good.
there are numerous times where you draw something or design something in the computer, and then you think it's going to work just fine, and if you don't have someone check your work, or if you don't have someone who has more experience in doing something you're not familiar with. So what I mean by that is, if you don't get the input of the person who's building whatever it is you designed, odds are you're going to miss something. And so I actually, just 2 weeks ago, something that I had designed a bracket to mount a sensor to, and I didn't ask the person who put the thing together to look at it for me. And when went to put it together, I completely forgot there was a shaft that went right through where I thought the sensor would go. And so the sensor wouldn't go together. We had to tweak it after the fact. And so what's nice about my work is that it doesn't. If I make a small mistake like that, there are no lives in danger. And so it's not so It's not so kind of um, easygoing when you are designing real helicopters. There's a lot more of a thorough analysis process. There's a lot more of a thorough checks and balance process, because in those instances, if you make a small mistake like that, there could be real ramifications. People could get hurt. And so,
Because you're more on like the experimental end of things before things actually go into production. You don't have to worry so much about like the total safety of everything. You're kind of way before that, so you can kind of be more creative.
yeah, and maybe not creative. That might be not be the right word, but you
Less
can be,
I guess.
yeah, you can be a little less thorough, and but as a result, you can be it's but as a result, you get to do a lot more, and it's a lot more fast paced, and so it's fun. It's R&D, I guess I would say.
Yeah, as opposed to just sitting there and testing the same screw you've been using the entire time over and over again, right?
Exactly.
So the next question I could have for you was, how long does it take to become an engineer? So yeah.
Good question. So there's a million different tracks you can go on this, and so there is no right way of doing it. The conventional means is going to engineering school, where you get a 4-year. You can go to college and get a 4-year engineering degree. I have a ton of coworkers who didn't go to engineering school at all, and they actually became engineers through a more technical, hands-on route. And so there are tracks available at probably most companies where you can become an engineer by being a technician or a tradesman, and um, from seeing enough and working on hands-on with the parts, you get a lot of experience, really valuable experience, and that would make you a great designer.
Wow, that's something
Um,
I just learned something. I didn't even know that you could go like work your way up that way. That's pretty interesting. I'm sure a lot of
Absolutely.
will be interested in that because they're deciding kind of right now in the 8th grade between whether they want to do like tech voc or do like the more standard high school path. So it's interesting to see that you can kind of make it to engineering through both sides of that. That's cool.
For sure. And so I mean, at least at my company, there's not as many engineers that I know, and like the engineering in, like, the broad sense of an engineer. There are more who go through the traditional college route than they do the tech voc route.
Yeah.
But having said that, there are other, if you would rather do hands-on stuff, you can go and get your engineering technology degree, which is a 4-year degree. But my cousin's doing this down in North Carolina. It's a hands-on degree that's less theoretical and more about relevant practical skills. And so there's a lot of different options.
That's good to know. No, that's interesting. Cool.
Yeah, it's really interesting. It's cool.
All right. So then, what kind? So the last question the kids have for you is, how is engineering related to physics? We actually just did a little bit of physics before we went on our big break. So, go
Cool.
ahead.
Oh, great question. I love that. So my background, I did a non-conventional engineering degree. I did a 3-year and a 2-year program. I did 3 years in getting a physics degree, and then 2 years getting a mechanical engineering degree. And so let's think. The physics. Well, the obvious answer is engineering, especially mechanical engineering. It's all about free body diagrams, and physics is all about free body diagrams. And so there's a ton of crossover, and that's at the very fundamental level of both of those degrees. The engineering, you have to take statics when you start, which is pretty much just free body diagrams, and then in physics, you have to take physics 1 and 2, which is all about free body diagrams.
So
And
perfect.
so, yeah, it's perfect. You get a lot of crossover. And then if you want to pursue even higher education, then there's a lot more crossover between like higher level math skills that you learn from physics and the higher level theoretical engineering courses that you could take.
That's cool.
So they actually are very comparable and compatible.
That's awesome. So when you're looking at a free body diagram, that's all about looking at different forces and interactions, right? Like that's
Exactly. Just all about the forces. Yeah. A new word that I learned while I was working was called load paths. And so what that is, and that's still very hard for me to wrap my brain around. But it's kind of like if you have a bunch of parts stacked on top of each other, and if you put like a force in one of them, how does the force go through the parts and ultimately come out? And so that's something they didn't really cover very well in school, but there's a very big emphasis in the workforce, and something that's been very interesting for me to learn about. So
yeah.
you're always learning. That's, I think,
Yeah.
one of the best parts about getting older.
Absolutely, man. There's plenty of stuff that you don't learn in school that shows up at your job, no matter what you're doing. Absolutely.
Exactly.
Asset management or load paths, I guess. There you go.
Yeah.
All right, now we have two fun questions for you. When you were designing those cars with your team in college, did you get to drive the car at all?
Oh gosh, great question, and I'm a little bitter about this. So I was on the team for 2 years. My first year, I got to drive the car, and that was what did it for me. I was so into it after that point. It was super fun. It was like a go-kart on steroids, I would say. And then my second year, I had a lot more responsibility, and I was so busy, I never got to drive. So I think the takeaway from that is don't get too involved, so you get to have the fun stuff.
You were too busy doing all the math and doing all the tests down in the lab, and you didn't get to drive anymore.
Exactly. Well, actually, what happened was he never got our car to work. So I would say that's my biggest failure of my engineering career.
Year one, so not so good. Year two, is it the first year or the second year that it fell off the back of the trailer on you? That's another.
That was the first year. Oh, that was probably the most stressful moment of my of my school life. That was horrible.
So our last and most interesting question, that we're all going to judge you on. What's your favorite Disney movie?
Oh my goodness, what a great question and incredibly relevant. I love it. Oh gosh, it's a tough one. There's so many good ones out there. The first movie that jumps to my mind is Incredibles. I could probably quote that entire movie line by line to you guys. So I think that would probably be my favorite. But I love Mulan. I love.
Listen to Let's Get Down to Business when we clean up in class. So.
Oh my God, that's great. You can't get more inspired than that.
So inspiring.
That's awesome. I'd say Incredibles and Mulan are my two favorites.
Perfect. All right. Well, thanks so much for doing this. It was awesome to get to talk to you, and I'm sure the kids will be really excited to hear all this. So.
Yeah, I'm so happy I could help. Yeah, good luck with your semesters, and I hope everyone stays safe.